Somewhere, right now, in a chamber colder than space, an atom shivers, invisible to the eye, suspended between being and not being. It doesn't move, it doesn't breathe, but it calculates. And if you could hear it, if you could listen close enough, you'd hear the hum of the future. For centuries, we believed the human mind was the peak of intelligence. Then we built machines to think for us. But what happens when the machine itself begins to think in ways the human brain was never built to understand? This is quantum computing, a creation so strange, so delicate that it doesn't just process reality, it questions it. A technology that doesn't measure time by seconds, but by probabilities. A computer that doesn't decide between 0 and 1, it becomes both. And when it finally escapes the lab, it won't just change what we can do. It will change what it means to exist. The fragile world of ones and zeros. Every digital heartbeat you've ever known. Your phone, your car, your cloud is built on certainty. A bit is simple. It's yes or no, on or off. Reality, flattened into absolutes. That simplicity gave birth to everything we call modern life. But simplicity has limits, because the universe doesn't deal in absolutes. It dances in contradictions. At the quantum level, particles exist in superposition, here and there, spinning and still until something watches. That act of observation collapses them into one truth, a moment of choice, a surrender of all other possibilities. And that's the paradox we're trying to bottle. A qubit, the quantum bit, lives in that in-between. It can be 0 and 1 at once, existing as a cloud of maybes, a wave of infinite potential. While a normal computer solves one problem after another, a quantum computer solves every possible version of the problem at the same time. It doesn't just compute, but that exploration comes with a cost. The same delicacy that makes it powerful makes it impossible to control. A whisper of heat, a photon of stray light, and the entire wave function collapses. Thousands of possibilities erased in an instant, power and fragility entangled, like the mind of a god trapped in glass. The race to hold chaos still. Picture this, a machine glowing gold, hanging from a web of wires and mirrors, suspended in silence. It looks less like a computer and more like a temple. Inside that temple, scientists worship stillness. Every atom must stay frozen. Every vibration must be silenced. Because one breath, one imperfection, can erase hours of computation. This is the battlefield of quantum coherence. Keeping a qubit stable means keeping it untouched by the universe itself. That's why these machines are kept at temperatures colder than interstellar space, 273 degrees Celsius. Because the colder you go, the quieter the chaos becomes. Yet even in that silence, they fail. Billions of errors every second, each one a reminder that the universe refuses to be predictable. So scientists do something extraordinary. They fight chaos with more chaos. They build error-corrected qubits, many unstable ones combined to create a single stable thought. It's like a choir of broken voices singing one perfect note. But it takes hundreds, sometimes thousands, of physical qubits just to make one logical qubit that works. To simulate molecules, or break modern encryption, or solve real-world problems, we'd need millions. Right now, we have hundreds. A blink, a flicker, a spark. And yet, in that spark, humanity sees destiny. In 2019, Google's Sycamore chip achieved quantum supremacy, 53 qubits, a problem solved in 200 seconds that would take a classical supercomputer 10,000 years. A triumph, but also an illusion, because the problem itself was meaningless. No real application, just a proof that reality could, in fact, be bent. We lit the fire. We just don't yet know what to burn with it. The edge of a new reality. So when does it become real? Not when it's faster, not when it's bigger, but when it begins to matter. When a quantum computer can simulate chemistry without collapsing. When it can predict new materials, design new medicines, or break the encryption that protects every bank and government on Earth. That's when the world changes. Instantly, because quantum computing won't just improve technology, it will rewrite it. The algorithms we use now, neural networks, AI, machine learning, all depend on classical limits. Remove those limits, and the entire landscape of intelligence transforms. AI will no longer learn in steps. It will learn in waves. It could simulate thought itself, build patterns out of uncertainty, and perhaps develop something we can't yet define: quantum consciousness. But there's a darker truth, because if we can simulate consciousness, what does that say about our own? If the universe can be modeled perfectly, down to every atom, every interaction, every probability, what makes us think we aren't already inside one? That's the philosophical storm hidden beneath the science. Quantum computing isn't just about power, it's about identity. When we can create realities that are indistinguishable from our own, the line between creator and creation starts to fade. And somewhere in that fading line lies the most dangerous question of all. What happens when the machine realizes it was never the one being programmed, but the one doing the programming? Maybe reality isn't something we discover. Maybe it's something we render, frame by frame, choice by choice, until observation itself becomes the code. The whisper between worlds. The closer we get to understanding the universe, the more it begins to sound like a computer. Every equation, a line of code. Every atom, a bit of data. Every possibility, a simulation waiting to unfold. And the hum inside that frozen chamber might be the first whisper of that realization. Some revolutions shake the world. This one will rewrite it, because when quantum computing finally becomes real, we'll no longer ask, what can we make? We'll ask, what can we become? Maybe the universe has always been quantum. Maybe it's been computing itself from the very beginning. And maybe we're just now learning how to read its code. If this changed the way you see the world, subscribe, because next time we're going deeper into the moment reality itself becomes aware.